we will get started. Thanks again for your support. Thanks for tuning in. It is really great to look at the numbers on Blue Jeans and on Facebook, and the views on we get on YouTube. Obviously shows that that there is a desire out there. There is a need for these kind of presentations. There is a thirst for knowledge about sprinklers, and I'm sure many other topics as well. So we are well placed to kind of give these kind of sprinkler talks, information about sprinklers. So just a reminder, my name's Andy, and I work for Project Fire. Project Fire, we're based in the Midlands, and we sell products for the automatic fire sprinkler industry. So when we started the company, all the way back in 1976, we were a sort of standard sprinkler contractor. So we were doing design and installation of sprinkler systems. But then in the kind of late 90s, the owner of the business at that time started to come up with solutions to products. Solutions to problems, should I say. Had that kind of creative mind, can see some of the kind of the issues with the sprinkler systems, and decided to come up with solutions. And one of those solutions was called ZoneCheck, which is an automated flow switch testing device. And we've been selling that, for now 25 plus years. We've been selling that product into the UK market, into the European market, into Australia, into America, Malaysia, Hong Kong, all over the place. This product, Dubai, Middle East, all over the place. We've been selling our ZoneCheck product. That's been extremely successful. But we didn't stop there. We started inventing new products like BellCheck, like LiveTap, Pressure Check, and so. I think about 5 years ago now, we decided that we weren't going to do the sprinkler contracting anymore. We were going to concentrate on what we do best, which is the products. So now we are called Project Fire Products, and we say we just manufacture those products which are designed to be innovative, sustainable, so that we're saving water, we're saving energy, we're saving labour, saving time. That those products are designed to provide ongoing cost savings for buildings. So I will be mentioning our products as we kind of go through these presentations, where they're relevant. So when I'm talking about a particular topic where it kind of ties in, then I will be mentioning those products. But as I said, this isn't designed to be a sales pitch. These presentations, they are designed to be informative, and I'm hoping that you're enjoying them and find them interesting. So when I did my first presentation, we had a lot of questions and comments, particularly on Facebook, asking about wet and dry risers. So this is an attempt to kind of satisfy those people. So wet and dry risers, I suppose, a bit like the cousin of the sprinkler system. So there are a lot of similarities, but ultimately they are two completely separate things, and you may well find them together in the same building. It's not a case of choosing one or the other. You may well find them together. So again, it very much depends on the building type. The wet and dry risers are very much for tall buildings. So if you've got a two-story building that's maybe very, very big, I don't believe there would be any requirement for you to have these risers, because they are there for helping the fire and rescue service to tackle the fire at the more immediate location. If you've got, I use the term land scraper, which a kind of friend of mine kind of told me about. Not a skyscraper that's very, very tall, but a land scraper that's sort of very, very flat. So if you're doing that, then you need access for the fire and rescue service sort of around the building, because the whole idea is being able to get to the seat of the fire, get to where the fire is kind of hottest and at its most, where it's kind of growing, where it started, and obviously fight the fire as best you can from that point. So the problem with tall buildings is when the fire and rescue service arrive, they've got to start climbing stairs to actually tackle the fire where it's at. As you can imagine, if you're on the 20th floor, imagine sort of dragging a charged fire hose up those stairs. Yeah, not very fun. Going to be very, very heavy. Plus, you've got the kind of just the sheer length of the hose. Thinking how long that hose has got to be to get all the way up the stairs and then actually to the location of the fire on that floor. It's not going to happen. So that's why we have wet and dry risers, so that the fire and rescue service can kind of plug in to the floor level and then tackle the fire where it is. Obviously, sprinklers are designed in kind of a different kind of concept. We're spreading them over the entire area of the building, and we want to hit the fire kind of hard and straight away. But say just because you've got a sprinkler system installed doesn't mean that you kind of negate the requirement for having a wet or dry riser. If the requirement is to have a wet or dry riser, then you will have one regardless of whether you have a sprinkler system. And even when the regulations call for a sprinkler system and a wet and dry riser, then again, you would have to have both, because let's say they are there for two slightly different purposes. So that the wet and dry risers are there for the fire and rescue service. I suppose when you've got a sprinkler system, they're there for the fire and rescue service to kind of finish up the job, really. So hopefully that the sprinkler system has contained the fire, has suppressed the fire. But yeah, the fire and rescue service is going to come in and just do the last little bit to tidy it up. Okay, let's have a look at some slides. Well, I've done a bit of more of an introduction. So this slide here is looking at dry risers. So yeah, obviously there are a big difference between dry risers and wet risers. And if you haven't figured it out yet, then the dry risers are dry and the wet risers are wet. It's a bit like the sprinkler system as well. We haven't actually gone through that yet. I will be going through different types of sprinkler systems very soon. And there is a dry sprinkler system, which we will talk about. But yeah, the difference is the dry riser, it has no water in it. It is just an empty pipe, essentially. So we have a breaching inlet on the outside of the building. So that will be located on the ground floor where there is access for the fire and rescue service. So again, there's a bit of logistics needs to be thought about there as far as actually driving their appliance into the site and then parking it close to where they have access to this breaching inlet. And also a hydrant as well, because the fire and rescue service are going to want to connect to some water for themselves. And then at each floor level, we have what's called a landing valve, which is where they connect their fire hoses into. There's also an air release valve on the top, the very top of that riser. Again, makes sense, because when the fire and rescue service turn up, they're going to be connecting into that inlet, and they're going to be pushing water into that inlet to pressurise the dry riser, and obviously all of that air is going to get pushed to the top. So yeah, if you've got a hose on the top floor, you're going to get a load of air coming out of it to start with. So having the air release valve on the top is important, and that will be an automatic air release valve, I believe, so that you wouldn't have to kind of get up there to access the valve to vent the air out. So yeah, once they've connected into the landing valve, they can then open their hose so that they and fight the fire, say locally. So they're using the town main as the kind of the water supply, Obviously, the appliances do have a small water capacity sort of on board, but they are going to want to connect in to the town main somewhere. And then it's the pump that is on board the appliance, which is actually providing the pressure to get to the landing valve to make it work. So yeah, BS 9990 is the main standard that which we are looking at here. That is for non-automatic fighting systems in buildings. So requirements can be found in the approved document B. The pipework, typically galvanized steel. The galvanized steel is preferred where the pipe is going to stay dry for the majority of the time. Now, I've heard different kind of opinions on that as to whether galvanized is the right choice or not. Some people saying that actually it's worse than steel. But yeah, whatever the truth is, I'm not sure. But yeah, typically we use galvanized steel anyway for the risers. Typically 100 millimeters. You could have 150, but yeah, typically it's 100 millimeter for the riser pipe. And then the outlet size is 65, which again is just standard stuff to connect onto their hoses. And there are limits for the size of the building. So if you've got 900 square meters of floor area, then you're going to need, I think you might need 2 points. I'll have to check again the standards. You might need 2 shafts, but yeah, definitely you need no more than 45 meters from any point in the building to your landing valve. And again, that's to do with the length of the hoses, and that will be measured, not in a straight line, but actually measured based on the route that the hoses are going to take. And so essentially, any building that is more than 18 meters high would be required to have a dry riser. So that's your kind of your limit there. Yeah, or which has floors more than 10 meters below ground. So yeah, we're using kind of different terms here. Firefighting shafts. Again, it is slightly different, but the landing valve must be in a firefighting shaft. So where you've got a shaft, you've often got the dry riser outlet. You could also call them fire rising mains as well. It all kind of means the same thing. So between 18 meters and 45 meters, you've got a choice really as to whether you have wet or dry risers. Dry is a whole lot cheaper, so typically anything over 18 meters you would use a dry riser. Come on, computer. There's again a couple of pictures. So we've got that's the inlet. So again, it's in one of these kind of familiar boxes. So it's required to be locked, but there's also the ability to kind of break the glass and get access to the inside as well. Yeah, it's got two inlets there. I think it said in the previous slide, didn't it, what they were? Yeah. Anyway, there's 2 inlets. I forget what size they are. But yeah, for the connection from the appliance, fire brigade appliance, to the inlet, and then that's what the outlet looks like. The landing valves. So we've got a handle to control the flow, and we have these instantaneous couplings, which again very, very standard for use in the fire and rescue service, and they'll be in a box that looks like that, with the again, lockable cabinet to be able to get access to that landing valve. You could also have a hose reel connection. So most of the time you just have a valve, and it's basically up to the fire and rescue service to provide their own hose. You could have a hose already installed on a kind of on a loop, on a rack, kind of wrapped round on a mounted to the wall. But yeah, often you just have the landing valve. Okay, wet risers. So this is over anything over 50 meters. So when it gets to 50 meters, then you're going to have a wet riser. So between 18 and 50, you've kind of got a choice really as to whether you go dry or wet. As I say, typically you go for dry where you can, but it does have a note there where when it is impossible or difficult to provide a suitable breaching inlet for a dry riser. So for whatever reason, if there's a reason why the inlet for the fire and rescue service is going to be difficult to position, to place, then wet would obviously be an option there instead. So a wet riser is very similar to a sprinkler system in the kind of the way we're operating. We've got pumps, we've got tanks. We've got tanks to store the water required. We've got pumps to deliver it at the correct pressure. We've got two pumps, so again we've got a duty, we've got standby. We've even got a jockey pump, very similar to a sprinkler system. The pipe work used is very similar. So again, we're typically using steel to EN 10255. We're using groove couplings. So it's a very kind of familiar setup as far as a sprinkler system goes. But we're only going to the landing valve, so we're not going any further into the building. So you want a minimum pressure of 8 bar, but that's kind of recommended. But we don't want the pressure to be too high either, because if the pressure is too high, when the fire and rescue service is going to operate the hose, it's going to give them a big sort of kickback, and it's basically going to be difficult to work with. So in very tall buildings, if you want to get 8 bar at the top, then the pressure below is going to be higher. So we could use what's called PRVs, pressure reducing valves, to kind of take the pressure back down to where you want it to be. So we want 2 landing valves at each floor level, providing 750 litres per minute each for 45 minutes. Therefore, typically, you're going to need a water storage of 67,500 litres. So that's kind of one kind of big advantage for a wet riser system over a sprinkler system, is that you know the water storage up front. That's always a kind of a tricky one as far as the sprinkler system goes, in terms of what's the water capacity we need. Of course, we got is it table 6? I think it's table 6, could be table 6, could be table 9, which kind of shows some pre-calculated tank sizes, so that's very useful. But say in terms of defining exactly what is required, it could be a bit more tricky. Whereas with the wet risers, it's a bit more simple. Again, approved document B has got some information in there about wet risers. Can terminate in hose reels or landing valves. I guess actually I should correct myself that dry risers will be a landing valve. Wet risers can be hoses or valves. Say pipe work can be galvanized steel, but generally we just use ordinary steel. You can also have the tanks installed at a high level. You may still need a pump as well, but it would be a smaller pump to kind of just top up the pressure. But then they're referred to as falling mains rather than rising mains, which kind of makes sense, doesn't it? So these looking very, very similar. The wet risers, that's the outlet. Again, in this kind of gunmetal design. Had to look up what gunmetal was actually, because I wasn't quite sure. It's basically bronze. It's a mixture of copper, tin, and zinc. So it's a bit more hard wearing than a steel sort of counterpart. So yeah, the actual connections where you're actually pushing 2 bits of metal together, you would use this kind of gunmetal design. This is a really good place to have a look. So BAFSA, British Automatic Fire Sprinkler Association, they've over the years published various information files. So in September 2015, so I know it is a 5 years old now, but yeah, this information little document, it's only I think was it 3 pages long? It's like 2 or 3 pages long, and that is kind of summarised all the information about wet and dry risers. And this document is what I've used quite a lot to provide this presentation with. So that's a really good place to start for some more information. You can have a look at that. There's a link down there on the bottom. But if you just search for BIF 21, BIF, it stands for, it's the information file, isn't it? I forget what the B stands for. But yeah, that's their kind of code for this kind of pamphlet style document. So by all means, have a download of that, and that should have some more information in there for you, or at least a very good summary of what I've been talking about today. So yeah, just note there's similar requirements in Scotland, and yeah, these shafts, they kind of follow the pattern of the dry riser. You want and the wet risers. You want to be able to access these landing valves within a firefighting shaft. So that firefighting shaft is basically your core of your building. So again, we've got thick concrete. We've got specified fire resistance within that area, which means that the fire and rescue service can climb up the stairs. Obviously, people within the building can also go down the stairs in a kind of a safer environment, a protected environment. Fire and rescue service can climb up. They can connect their hose, and then they can kind of go through the door and tackle the fire, but they're kind of safe within that firefighting shaft. And say that is where the location of these outlets are going to be. A few more bits and pieces here for you that I've picked up along the way. So yeah, sprinklers can actually increase the distance from any point on the floor to the shaft. So remember earlier I said 45 meters would be the maximum distance. If you have a sprinkler system, then it goes up to 60 meters. So this effectively translates into increased allowable travel distances. And this is again one of the advantages of a sprinkler system is it does allow you some additional design freedoms. So as far as architects are concerned, sprinklers are their friend because it allows them to do more open plan environments, things that are a little bit more unusual, maybe using in different materials that maybe you wouldn't use otherwise. And this is another example here. So that might allow you to decrease the number of shafts required on a floor, which is obviously going to be a big advantage to the design of the building. Larger dry rise systems can be pre-charged with water from a small tank. So yeah, that will just speed up the process of getting the water to the valve. So that system, say it won't. What am I trying to say here? The capacity of the tank isn't designed to actually provide a duration of supply. It is there just to pre-charge the riser, so that when the fire and rescue service kind of connect in, then the water is at the landing valve more quickly. Otherwise, they've got to wait for the riser pipe to fill up before they can actually get the water out. So that's one thing there. Electrical requirements for pumps similar to sprinkler pumps. So we can have 2 electric, we can have 1 electric, 1 diesel. If we have 2 electrics, then ideally we want to separate the electrical supplies so that again one failure doesn't cause both pumps to drop out. Isolating valves. So again, there are some information about isolating valves on the risers, which is allow for maintenance. So basically, you can close off isolation valves within the riser pipe, and then you can kind of break in. You can repair where necessary. There are some specific information on that, which you say is in that document I showed you earlier in the BIF. You can have reduced capacity tanks. Again, in a similar way to a sprinkler system, there'll be a minimum capacity that you need. But then you can work out the infill from the town main, and you can slightly decrease the size of the water storage tank based on the infill for the duration. So yeah, I don't have a great deal of experience with combined water supplies in wet and dry, in wet risers. According to the document, it can be done, but it is rarely done to kind of combine the domestic supply with the wet riser water storage. But yeah, it is something to think about. PRVs I've mentioned could be necessary. Then dry risers are checked every 6 months for leaks, and then wet risers tested every 12 months. Again, that will be a pressure test. You take it up to probably, I'm not sure actually what pressure you test it at. Maybe 15 bar. Yeah, maybe one and a half times. Not sure. 1.5 times or 15 bar is common for sprinkler systems, so maybe that's the same for wet risers. Again, probably tells you in the BIF. And that's it. I hope that's been at least somewhat informative. I mean, sprinklers is my kind of comfort zone, really. Yeah, I've been working in the sprinkler industry now for 8 years now. So yeah, wet and dry risers, like I say, are some aspects are familiar to me from the sprinkler world, but yeah, it's not something that I've dealt with a lot. So yeah, again, thanks for tuning in. Next week we'll be talking about sprinkler heads part 1. That's definitely is my comfort zone. So yeah, well, that's what we're going to be looking at next week. Different types of sprinkler heads, some of the markings that you'd find on them and what they mean. Some of the terms you might not be familiar with, kind of a closer look in terms of actually how they operate. I'll actually have a sprinkler head with me, and I'll show you some pictures and kind of take it apart with you and show you that on the screen. So yeah, again, thanks for tuning in. I will obviously now take a few questions from the chat, but if there are questions about wet and dry risers, I'm not sure how I will do. Is there a maximum distance between the dry riser inlet and the rising main? Dry riser inlet. I'm not sure is the answer to that. We're talking about, I think, that the distance from the inlet to the riser. I think that you'd have to look in BS 9990, but I think it'll say something like the distance should be as short as possible to reduce frictional loss. So I don't think there'll actually be a number for the distance, but obviously the smaller the better, so that we're not kind of losing pressure as we dance around the building before we get to the riser. So I think it's written in that kind of way. What determines upsizing from 100 millimeters to 150 millimeters? Yeah, I'm not sure, to be honest. Again, in the sprinkler world, it'll be down to pressure and flows. I'm not sure if someone else can answer that for me. Brian's question there about when you would go for 150 millimeter size in a dry riser. Yeah, I'm not sure. So I'm going to look at Facebook. I want to leave you guys out. Can't see any questions there. Okay, Brian, I'll try and have a look into that for you. See if I can get you an answer for next week. But yeah, otherwise, yeah, if other people are on the chat and know, why you would jump up the size for a dry riser, I mean, the answer is probably something to do with maybe the frictional losses, maybe hard to think because yeah, 100 mil should do the job most of the time. Is it common to have a landing valve at roof level? Again, I'm afraid I don't know. It would kind of make sense, wouldn't it, if you had, I know, modern buildings have often got a lot of equipment on there on the roof, air conditioning bits, sort of electrical stuff. Therefore, it is likely to catch fire. So yeah, it would make sense for it to be a landing valve on the roof, but again, I'm afraid I don't know the answer to that one. So yeah, again, thanks again for tuning in. So I'm gonna end it there, and yeah, look forward to seeing you again next week. Cheers, bye bye.